Okay, so now we're going to go ahead and get started again. And we're going to finish up 1-7. And we still need to look at some special cases out of 1-7. There are times at which you'll get either no solution or an infinite number of solutions out of these. And these are going to be in our special cases. And these are special, they're going to be called special cases because on these special cases, the right side will be a negative number. Okay, so I want you to take a moment to think about this one. So that right side is going to be a negative number. Now, this is going to be a special case. And these special cases are either true or they are false. Look at this -9 and look at the absolute value. Now, what do we know about an absolute value? By definition, an absolute value always comes out to be what? Positive or what? 0. Okay, so we're just going to assume it's positive for right now. If I assume that that is positive, now, is there any number that's positive that can ever equal a -9? Can that ever happen at all? No. So that would make this one then false, and that would have no solution. These are very simple, but these are the ones that students miss the most because they get in a hurry and they try to solve it. So because that was negative, that makes it a special case, and that is false. It doesn't matter what's in there. This one's also going to be a special case. So that -10, see, that makes it a special case. Now, what do we know about absolute values? These special cases, we don't have to work them all the way out. They're either true or false. Okay, that's it. So, what do we know about an absolute value? What does it give you out? It gives you out either positive numbers or what? 0. Okay, so we're just going to say it's positive. Now, it could be 0, but that's not really that important. The positive part is. Okay, so can a positive number ever equal a -10? Can that ever happen? Is there a positive number that equals -10? No. So that is false, and that means you have what? No solution. Because no matter what number you plug in, your answer is always going to be at the smallest 0 or a positive number. And so it can never be a negative number, so it has no solution. You may have to move numbers around before you start solving, just like before. Now this one is going to behave just like the last ones. Before we start looking at it, though, what's the very first thing that we must do? We must move what over? For anything else, always move that 15 over so that that absolute value is by itself on the left. And then we've got 8 minus 15. That makes it then a minus 7. And again, that negative there, that makes it a special case. We know then that positive numbers can never equal a negative 7. So again, what is that? That is false. And what's my solution? The empty or the null set. All the special cases are either going to be true, meaning everything, or false, meaning nothing. So let's look at a couple more. Now we're going to look at inequalities and see how these are a little bit different. Absolute value of minus 8x plus 4 is less than, how about a negative 13? So right off the bat, I should already understand that this is going to be a special case because of that negative. So that negative 13, well, that makes it again a special case. What do we know about absolute values again? Absolute values are positive. Okay. Now reference the absolute the positive numbers with that negative 13. Look at the way it points. This is saying that positive numbers are always going to be smaller than that negative 13. Are positive numbers smaller than negative 13? True or false? No, they're larger. So that would make this then again what? False. And that would make it then what? No solution. The next one's going to be a true statement. So we'll do the next one that'll make it true. These can either be true or false. You just assume it's positive and see if it's true or false from there, depending upon what you got. How about the absolute value of minus 12x minus 8 plus 10 is greater than or equal to 4. Okay, and the directions here are going to be solved. So what do we do first? Again, before anything else, move that 10 over. Always do that first. Now, do we have to go through and solve this at all? No. This one's either going to be true or it's going to be false. And what makes that determination? Why do we know that we don't have to solve it out? Because that's a negative 60. So that again makes it a special case. If you try to solve it out, you'll get the incorrect answers. So this is a special case. Now, what do we know about these absolute values? We're going to assume they're positive. They can be 0 as well. But let's assume it's positive. And our positive numbers, now, are they bigger than a negative 6? Would that be true or would that be false? Well, in this case, that would make that true. And if it's true, what does that mean? If it's true, then that means my solution set is negative to positive infinity. Now I'm going to give you another one, and this one we're going to use a different variable in it. And we're going to have to think about what we've got here and how it's going to work. So we find one kind of like what you've got in the homework here. Well, this is going to be kind of like something on the practice exam. About the absolute value of 3k minus 2 is greater than or equal to a if a is less than 0. Now, how is this one different? Well, we have all these different variables, right? We don't know what any of the variables are. So how would we work this one out then? Well, what do we know about a? Okay, a is less than 0, right? So that means that we need to pick a value of a that is less than 0 to use. So we're going to pick a value that is less than 0. So how about we use a is negative 2? And we can check, because is negative 2 less than 0? Yes. Now we can see what we've got. You could have used negative 1. You could have used negative 12. It doesn't matter what you use as long as it's a negative number. So I just simply picked a value that's negative because it tells you that a must be negative. Okay, now what do we know? Well, again, this is negative, so what does that do? That makes it, again, a special case. So we know that this side with the absolute value is positive, and our positive numbers greater than a negative 2. Is that true or is that false now? Can someone tell me? True. If that is then true, what would my solution set be? My solution set would then be negative to positive infinity. Let's do one with a 0 in it, and this is going to be like 13 in your homework. Just to make sure we've covered all of our different parts here. So we're going to look at something like 13. Not 13, but we'll do something similar to it. I just changed it to a different variable. Notice that 0 again. What do we know about absolute values? They're positive or 0, right? It would make a difference if it had the underscore bar, but it doesn't. Okay, so this is saying that positive numbers or 0 are always going to be smaller than 0. Are positive numbers or 0, are they smaller than 0? Is that true or is that false? Positive numbers are not less than 0, so that would make that then what? False, right? Okay, because these are going to be larger. So that's false. So what would your solution be? Your solution would be the empty or the null set. If it was going to be greater than or equal to 0, we had the equal bar underneath and the inequality was flipped, then it would be true. Okay, but positive numbers are not smaller than 0. That's false. And that's very, very similar to question 13 in your homework. Now we're going to look at some cases. And this is the way the textbook has you solve these. And we're really not going to use them much. But if you have college algebra with a different instructor, they may use the cases. So we're going to talk about the cases quickly. And then we're going to look at some questions that involve these in our homework. And this, by the way, is on page 126. So page 126. Now, we have already done these. We do them in a different way, but it's the exact same solution. The equals. Okay, we do the equals the same way that they do. If you've got an absolute value equaling a number, then what you do is you get your two equations. That's the way we did it, right? Now, they put them on the number line. We don't, because we don't need to, but they're just dots on a number line. So that's nothing new. Case 2 and 3, we solve them a little bit differently than they do, because I think this way is more confusing. They use single inequalities or a double down here. But you get the same solution, because remember, we get some of them that look like this, and we got some of them that look like this. Now, the important part to note on these is the fact that it's opening towards the absolute value. And if it opens towards the absolute value, it has an or in between. If it's opening towards the number on the right, then it's a double inequality like this. Now let's look at a couple of questions from our homework. And these are the multiple choice questions. We're going to go through these just so we talked about them a little bit. And we're going to look at our homework. We're going to begin with question 12, because I think that's the first one. Okay, so we're going to use this table to talk about what our equations would look like here. So this is 12 in your homework. And we're going to go through 12 and 14. And those are the only two that I gave you. Okay, so let's look at this one here. Now, when we look at these, first thing we need to look at is figure out which case it is. And so we look at the inequality. And the inequality is opening towards the number. So it's not case 1. Okay, because case 1 is the equals, right? Zoom out a little bit so it's easier to see. These are hard to read. So it's not this one. Look at this one. Is it this one? Nope, it's not that one either. And what about the last one here? It looks like it's this one, doesn't it? Right? You see how you got the inequality opening towards the number. Now, what does it look like? How do we solve it? We use a double inequality. Notice which way they're going. So look at your choices here. Which one is it going to be? Well, we know it's not A because the inequality is going the wrong direction. We know it's not D because it's only part of it, right? And these are just using the cases. Now, these are not going to be on your exam, so you don't have to worry about that. But I want to show you the cases because many instructors use the cases. I don't. I have you check numbers, but depending upon who you have for college algebra, they may use the cases. What's the difference between B and C? Yep, the inequalities, right? Now look at the way they go. Notice they all open to the right. So this one is not going to work for us. Why not? Because that inequality is wrong. This one would be the correct answer. So what would be our answer on that one? If we were to solve this using the cases, we would use B. And there's only 2 of these in your homework. I'm going to go through them. None of them like this are on your exam. I just want to at least talk a little bit about the cases. I personally don't use the cases because I think the cases are kind of confusing. Now look at 14. Which way is 14 opening? It's opening towards the absolute value, right? Okay, so let's go back and look at our cases. It looks like it's going to be this one, doesn't it? Case 2. Now, very, very important, look at what's in between them. When we go to solve these, what's in between them? And 4. So which choices can I get rid of now? I can get rid of which 2 just by that fact? Yep, I can get rid of B and what? D. Why? Because those are ands. Now we know it's an or. Okay, go back and look at your signs. Which way do they go? This one opens towards the ax plus b. This one opens towards the negative c. So look and see which ones we've got here. A is not going to work. Why is A not going to work? Inequality is going the wrong way. So which one would then be the correct answer? The correct answer would be what? C. Those are the only two of those I gave you. I didn't give you any of these on your exam. I just want you to kind of be familiar a little bit with the different cases. I don't use the cases. A lot of instructors do, though. So at least we've talked about the cases a bit. So what we've got left now is we've got a few minutes to look at some questions off of the practice exam. Now I am going to post a worked out copy of your practice exam online. I've already got that made up. And so I'll post that with the notes today. We're going to go through some that I think we struggle with. So I'm going to pick out some that I know students are likely to make mistakes on. So now we're going to just look at a few on your practice exam. And we will have time next week before we take our exam to answer more questions also. But we only have about 30 minutes left. So I'm going to pick the ones that I know students are very, very likely to make mistakes on. So in the back of your packet, you've got that practice exam. Now, by the way, your exam next week is going to have probably 22 questions. You're going to be able to skip 2 of them. So there's 25 questions on this practice exam. If you see it on the practice exam, it's going to be on the real exam. They're just different numbers in a different order. So they're mixed up. I changed the wording on the applications, but the same type of question, same type of problem. Now, you're only going to be responsible for 20 of them, but I'll probably put on your exam next week 22, and you can skip 2 of them. So that'll allow you to skip 2 applications or maybe 2 inequalities, whatever you would like to do. So that's what will happen next week. Also, next week, what can you have on your exam? You can either have a page of notes, front and back, or several note cards. And I don't really put a limit on the number of note cards. Note cards, I think, are very beneficial. If you want to bring in like 10 or 15 of them, that's great. Okay, so you can either have a page of notes, front and back, or note cards for your exam next week. But let's look at some questions off of our practice exam. And I'm going to pick out the questions that I know students struggle with the most. Students are most likely to miss these. Question 4. We went over it earlier, but we're going to do it again. So we've got this. And this is a commonly missed question. We went over it a few moments ago. This will probably be on your exam. Now, I might switch the inequality around. I might switch the direction of the symbol. That will be about it, and the numbers. How would we work this one out? This one has a condition, and what is the condition? It says k is less than what? 0. So we pick a value for k that is less than 0. Does not matter what we pick. So let's pick k equals a -1. And is -1 less than 0? Yes. So that means then that we can plug in that -1. Okay, what will we do here? Now, what is this now? Since we use that -1, what does this make this? Special case. That means it's either true or it's false. We do not have to work it out. Our positive numbers larger than 0. Is that true or is that false? True. Since it's true, then what would your solution set be? My solution set would be negative to positive infinity. On your exam next week, I might switch the inequality symbol the other direction. And I might make that f a z. And I might make it a 3z minus 12 instead of a 4f minus 6. But same type of problem. Okay, so there's going to be one just like that. So know how to do one like that. Different numbers, might switch the inequality around. Same concept though. True or false. It's easy, and I don't want you to miss that.
So you said there's going to be 22 questions.
Yep. So I'll pick out 22 of the 25. And then you're going to be able to skip 2 of them on your exam next week.
You get extra credit for the, like, just if you answer the
Nope, because all I'll do is you'll mark out which ones you don't want me to grade, or I'll just grade the first 20. So you'll be able to figure out, when you work with the exam, you'll know which ones you probably don't want to do. So you could skip 2 of them next week. So there'll be 22 questions, and they're going to come from these 25, and you'll be able to skip 2 of them on your exam next week. But you can't just do them all, and I grade them and figure out which ones you missed. Now, you need to figure out which ones you don't want me to grade. But you'll be able to skip 2 of them. Okay. Another one that students struggle with, and we went over this one a lot too, is question 6. And this we covered way back in 1.2. And this is a literal equation. And when we talk about literal equations are equations that have more than one variable. And there's only one of these on your exam. And we need to solve this for a specific variable. And what does it mean when I say solve it? Well, when I say solve it, that means we get that variable by itself on the left. Now, we are solving for the variable p. So my goal is going to be to get those 2 green boxes that have the variable p on the left. And everything else must go to the right. So I'm going to go ahead and move that 8s over. And then I'm also going to move that TP over. Now I can rewrite this as 9p minus TP equals a minus 8s minus 9. So what did I do? Let's take a moment to talk about this. Now you could do it in 2 steps if you want, but what are we trying to do? We are trying to get everything that has a p on the left-hand side. So I move that t times p over. And that 8s, does it have a p attached to it? No. So it moves to the right. Now we need to factor. On the left-hand side, what do these have in common? Well, these both have the variable p in common, and that's what we're solving for. So we're going to factor that p out. And then how do we finish it? We want to get this p by itself. So how do I get rid of that 9 minus t? It's multiplication. So we get rid of it by dividing. Those could cancel. Okay, because those can cancel out. And what does that leave you with then? That leaves you now with p equals a minus 8s minus 9 over 9 minus t. Now, this is one you may choose to skip. But if you choose to skip this one, then you're going to have to do the applications. Another commonly missed one is question 7. Now, question 7, students a lot of times don't finish it out completely. They only finish it out about 3/4 of the way. And so they get an answer, but they don't get the complete answer. So on question 7, we've got a triangle. And this is one that students don't struggle with. They just don't finish it because they get X, but X is not going to be my final answer. It's only part of the answer. So what do we know about this triangle? We know that it has to sum to what? It's a triangle. Yep. So it sums to 180. Nothing new there. So now we've got 2x plus 156 plus x equals 180. Students generally do not struggle with this part. It's the last step where we forget to finish it. So combining, that makes it 4x plus 156 equals 180. We'll move that 156 over. And now we've got 4x equals now 24. We'll divide that by 4. And then we get x equals now 6. But that is not my complete answer. Okay, this is what happens is students work out this question and they say 6 is my answer. That is not your answer. You need to find all 3 of the angles. So that means you've got to plug that 6 back in. So we're now going to take that 6 and we're going to plug it back in. So that's going to be 2 times the 6 plus 156. Okay, so 2 times the 6, that's 12, plus 156. That makes it 168 degrees. This one is x, so that's 6 degrees. And this one's also x, so that's 6 degrees. So what are my answers? We have to make sure that we get all 3 of them. So we've got 6 degrees, and 168 degrees. But again, commonly made mistake, and I guarantee probably 2 or 3 of you will do this in this class, is you'll stop there. That is not your final answer. If you did that, you would probably get, they're each worth 5 points, so that would probably be 3 out of 5 if you stopped at the 6. If you want to get full credit, you would have to finish it out and get all 3 angles. But that is a commonly made mistake. We've got a little bit of time left to look at some others. Another commonly made mistake with these is question 11. Question 11 is an easy question, but students a lot of times don't really know how to approach it and what to do. So what we've got is we've got an inequality. And I want you to tell me which one of these is the same as a is greater than or equal to that -1. Now let's remember what happens when we divide by a negative. When we divide by a negative, what happens to my inequality symbol? They switch. Okay, so only one of these is going to be the same as that a is greater than or equal to a -1. So let's work out each one of these until we find the one that is the same. So we're now going to look at this. We're going to look at question 11. Again, this is on your practice exam. And we want a greater than or equal to a negative 1. So we're going to go through our 4 choices, and we're going to see which one is correct. So the first one is negative 4a is greater than or equal to 4. Okay. Now, when we divide by a negative, what happens to my inequality now? We're just taking these out and we're solving them. It flips. Okay, so now negative and over positive makes it a negative 1. And is that what we want? No. Why not? We want that. Inequality symbol's going the wrong way. Part B. Part B is minus 4a is less than or equal to a negative 4. Divide by that negative 4. Your inequality does switch, but there's a mistake here. Negative over negative makes that then a what? Positive 1. Is that what we want? Nope, we want that negative. So that one doesn't work. What about C? Well, part C is negative 4a is greater than or equal to a negative 4. Well, that one's not going to work either, is it? Because we'll divide by our negative 4, and that's going to make it completely wrong because we switch our inequality, and negative over negative makes it a positive 1. So is C going to work here? Nope. D should work. Let's make sure that D does work. D is minus 4a is less than or equal to 4. Now, this one is going to work for us, right? Okay, because when we divide by that negative 4, what then happens to my inequality? My inequality gets flipped, so that's what we want. And positive over negative makes it a negative a there. Is that what I want? Yes, this is what I want. So your answer on that one would be what? D. I like this one. It's a good exercise in switching inequalities and remembering your signs. That's why I picked this one for your exam, and it's easy. Most of the questions on your exam are going to be simpler than your homework. But do we see how that one works? So there'll be one on there, and that's one you really wouldn't want to skip. It's pretty easy. If you can remember, you divide, you switch your inequality symbols, that one's pretty easy to work out. So that would be one that you wouldn't want to skip. Okay, we've got enough time to do maybe 1 or 2 more. 19. 19 is one that in the past has given students a lot of problems also. And students struggle with this one because it looks a lot more complicated and difficult to work with than what it actually is. So here's the question. Now, on your exam, you may or may not have this one. If you do, it's going to have different numbers, but very, very similar. So it might be, let's say it might be a 3, an 8, and a 4, something like that. instead of that 27, 54, and 18. And then it might be x plus 12, 3x minus 2, and x minus 3. I don't know, but it'll be very similar. How do we handle this one? Students struggle with this because of all the different fractions. And so what we do, we went over these way back in 1-1, is we take it and we split it up. And we split it into individual fractions. And so we're going to rewrite this into all these individual fractions. And then we'll clear them out. So we're going to rewrite this as individual parts. So that's x over 27 minus 6 over 27 plus x over 54 plus 3 over 54. That equals x over 18 minus 3 over 18. So what can we use to clear out my denominators? Well, what's my largest denominator? It's 54. Let's see if it'll go into 27. It should, but we're going to see if it'll work just to make sure. So 54 divided by 27 is what? 2. I know it's hard to see with the glare sometimes, but 54 over 27 is 2, so that works. We also have that 18. Okay, 54 divided by 18 is what? 3. So what's my least common denominator now? 54. It's the largest number. It happens to go into all 3 of them. So multiply everything by a 54. Reviewing the process. How do we clear these fractions? Divide by the number down below. Multiply by the number on the top. So 54 divided by 27. We did that a moment ago. 54 divided by 27 was a 2. Times x, that makes it a 2x. 27 divided by 54 again is a 2. Times a negative 6 makes it a negative 12. 54 and 54 cancel. That leaves you with an x. 54 and 54 cancel, leaving you with a 3. 54 divided by 18 is a 3 times x. That makes it a 3x. 54 divided by 18 is a 3 times a negative 3. Well, that makes that then a negative 9. Combine like terms and see what we've got. These go together, and that makes that then 3x minus 9 on the left, 3x minus 9 on the right. Does anyone remember what this would be? Identity. And what's the solution set for an identity? Yep, all real numbers. I'll write that out as all real numbers. And you could use negative to positive infinity. That would be fine as well. But I will just write that out as all real numbers. That way it's consistent with our textbook. We really don't have enough time to do any more. But remember, I'm going to post how I worked up all the questions on this practice exam with the notes today. So that'll be in the notes in Blackboard, in an email, just like they always are. But it'll have worked out practice exam. We'll have the notes in the video lecture for today. Now, just so we know, what do we have planned for next week? Just so everyone's on the same page. Our exam is next week. And what do we need to make sure we have done for next week? All that homework. So next week, you're going to turn in the homework packet. So make sure you turn that in next week. What can you have on that exam? What do you need to bring for the exam next week?
No cards or-
Yep. Okay. For the exam next week, you can either have a page of notes, front and back, or note cards. You'll also want to bring a calculator, so make sure you bring a calculator. And then you'll also want to bring in some scratch paper.